Good morning, everyone. I'm Hari, and my project name is Classification and Segmentation of Plant Diseases using ADAM optimization based upon deep neural networks. Here, in this project, a plant disease detection based upon deep neural networks is proposed. Initially, a CNN architecture based on DenseNet is used to train a dataset, and we are using Colab platform for efficient usage, and it is having inbuilt GPU. And we are collecting the data sets from Kaggle and storing it in Drive, Google Drive. Yeah. Then here the first code snippet shows that here we are mounted the drive with Collab. That means already we have stored the data sets in Drive. And next the import statements. Here we are importing NumPy, Pandas, OS. Here we are importing the libraries to define the directory. And this code snippet shows that here we are defining the diseases, like we are having so many types of diseases. Based upon it we are differentiating. And this train data code snippet shows that here we are creating data frames of data sets that we have mounted from Drive. Yeah. Next, this plot a histogram. This graph shows that here we are providing visualization of dataset for following grid view of leaf dataset. Yeah, this rest will be continued by my teammate Chaitanya. Yeah, Chaitanya, carry on.
Um, uh, Thank you, Mankanda. Good morning, everyone. My name is Chaitanya. I'm going to further explain the pre-processing and model development of the project. And here, the below shown code snippet shows the image reading from the file path that has been defined above. And here we are normalizing the data so that the model can be trained based upon a range of number, because a picture is defined in a value range of 0 to 225. So we are normalizing it to 0 to 1 so that the accuracy can be improved. The second code block which we can see here defines the code for the normalization of the data. And Manikanda, can you play it? Yeah, okay, pause it here. Yeah, here below we are splitting the data set into two parts. One is the training data set and another is the test data set. And we are doing that in a percentage ratio of 80 is to 20. 80% is the training data set and 20% is the testing data set. And here is a nice visualization of the data set with the disease types mentioned above them. Uh, okay, Manikanda, you can play here. And okay, pause it here. Here is the main code block of our project. Here is the model code for the model, and here we are using the transfer learning technique called DenseNet. Why we are using transfer learning technique? Because transfer learning models are the models which have been trained by the big IT companies like Google, Microsoft, uh, Kaggle, Keras, and these models have been trained on thousands. I mean, say millions of images, and these models have a much more better weights when compared to models trained on a less images, because these have been trained on much much and larger data sets, and so we are using transfer learning to make use of those weights, so that our model training takes place in a very less time. Okay, Mankanda, can you play it from here? Yeah, okay. A little bit. You have been forwarded a little bit more. Please go backward. Yeah, okay. Here, pause it. Here we are using the Adam optimizer, because it is the most common optimizer used in uh, machine learning, because it helps in achieving the pivot point very easily. And we are using the loss function, loss function called categorical cross entropy. And we are making the matrix to focus more on the accuracy, compared to other properties. And here the below code snippet, we are augmenting the data to avoid the uh, data set overfitting, we which we are achieving using the image data generator. The data overfitting problem occurs when a particular same image has been shown to the model again and again. It get used to the same type of image shape and size and position. So uh, when the same image is shown with a different rotation or different shape or size, and the accuracy of the model decreases. So we are data augmenting the data set, so that we can get rid of the data overfitting problem. Okay, Mangan, you can play it from now. Yeah, a little bit more. Here we are evaluating the model. Okay, Mangan, you can pause here. Here we are evaluating the model using the model.evaluate, and we are getting a final accuracy of 0.86% and a final loss of 0.75%. And below, okay, Mankanta, you can play it from here. And below we are using, okay, Mankanta, going too fast, a little bit backward, more. Yeah, here we are using the confusion matrix, to show the number of times the model actually have predicted right. And it has predicted very well, and it has done very well. And okay, Manganda, you can play it from here. And the code snippet is plotting the graph for the model accuracy versus the epoch, and model loss versus the epoch. Okay, I'm going to play it from here. Yeah, okay, little bit more down. Yeah, finally we are saving this model in the drive, so that we can use that model once again, so that we don't need to train that model again and again. And the further testing process of our project will be explained by my teammate Subbareddy. Subbareddy, please carry on.
Thank you, Chaitanya. Good morning, all. I am Venkat Subbareddy. Now I am going to show the further implementation of our project. Now, Mani, can you please play the video? Here now we are using a new Google Colab notebook because because if you train once, and we'll use only once in our Google Colab notebook. This new notebook is used in such a way that if you train once and save the model as we shown before, model.h5, and we can use the same model here, which is used for further testing n number of images at a time, means one by one. Here we are mounting the Google Drive
which consists of data sets that we have downloaded from Kaggle. And next, we are importing all the libraries which are required, such as NumPy, Pandas, and other all which is needed. These are the plant diseases as mentioned. This final model.h5, this is the model which we have saved before, and now we are using for our further implementation. Yeah, this is the model, and now we are using this for our further implementation to train again, to test the images again. Can you please play the video? For example, here I am taking a image from a plant healthy. Means these all images have no diseases. And let us take one image and test it. We should just copy the path of that photo image, and we need to load that image, which is used to detect the images whether it has a disease or not from a trained data set. And also we'll show the image, we'll display the image with the predicted output. Here the image is converted into an array, and then we are expanding the dimensions as per our requirements. Here the prediction is tomato healthy, and this is the image which we just loaded and predicted. Here we will use the argmax function to predict the output. Let us take another example. And we need to repeat the same process. We need to load the image, and again that show the image. The show image is used just to show the image, and load the image, load image that will load checks in the trained data set and gives the highly matched output. And here it is the tomato healthy. In such a way, we can test the plant leaves. Thank you.
Yeah, thank you very much.
ఆ కుక్క ఏంట్రా అల్లి లాస్ట్ లో